Hello, viewers. This is a clueless minimal increment demo. By introducing the A team, let me begin. Anthony Mora, the lead programmer, a talented Python developer. Fritz Wesselhoft, functioning as the lead architect and talented in his own ways. Nagila Mulati, as quality assurance lead, her efforts have guided error minimized development. Rem Houghton, primarily a systems analyst, when existing information system documentation was sparse, Rem Houghton gave wise information. Also, for the target increment, Rem Houghton shall serve as a GUI designer. Finally, you have been listening to Jonathan M. Kelly, project manager. My primary job function is communication. Plus, given the specialized talents our team already has, I perform systems analyst duties. Together, we are the A team, and I hope you, viewer, are impressed. In this slide, you, viewer, may see a completed work overview. The completed work is the following: Team Charter Revision. No longer a planned 24-hour, 7-day, 12-month, year-long available production. Instead, this is on demand, to the critical path's final deadline. Next, there is no more two-reviewer approval necessity. Since the lead programmer Anthony Mora did almost all major requirements for the code, Anthony has become the de facto programming decision maker. Next is the skeletal increment and the vision. Since the skeletal increment, our vision remains the same. For most ages, a fun and event-focused game experience. The requirements document revision is next. On-demand availability and critical path availability for the A-team. In 3 time zones we are located, thus this lowered overhead. From 3 to 5 players, the maximum players has increased. For brevity, you, viewer, shall witness a 4-player session. Next is the skeletal increment itself. The bone and marrow, networking, game initialization, and game choices to conclusion. Next is the design document. The project vision divided the project plan. In people, processes, and tools, project modularity has increased presence. Next is the minimal increment. From 8 classes to 4 classes. A TUI, that is a text-based user interface. As a text-based game, Clueless functions well. There is multiplayer board traversal through the rooms and the hallway. There is increased server-player communication, card data, card information, and disproving suggestions. Next is Fritz Wesselhoft, who shall discuss Clueless tools and architecture. Thank you for watching.
Hi everybody, my name is Fritz Wesselhoff and I will talk a little bit about the different tools and technologies that we have used until now in order to make this minimal increment of the Clueless game a reality. The illustration that I'm showing, it does not only shows the different tools, but also the different communication paths that both the Clueless game players and also the members of the A team have used during this semester. For instance, you can see here the members of the A team have been able to use an internet connection in order to authenticate in the AWS IAM service. So we have used this service in order to access the management portal of AWS. From within the AWS management portal, all the members of the A team have had the different permissions and policies in order to manipulate and make changes in both the game server and also the access control list. So we have used this service in order to stop the server, start the server, maybe restart, terminate, add access control rules such as authorized IP addresses and authorized ports as part of the security groups and also as part of the network access control list. And also we have used this access in order to be able to see the metrics of the EC2 servers. So metrics give us a lot of different values such as operation values, health values, activity values, also billing values. So this is just the management portal for us to basically manage the infrastructure. Another path that we have used, another communication path that we have used to interact with AWS is just using an IDE. For this example, I'm using a PyCharm as my representation, but this applies to any IDE. So basically, the members of the A team have used their local IDE in order to write and push that code to GitHub. GitHub is our version control repository. We have used this to not just to commit our changes, but to keep track on the changes and to be able to revert in case the latest commit created any issues or any bugs or any misbehavior of the code. So this is another path. So how this works is the members of the team basically code push to version control GitHub, and from here we could clone this repository into the game servers, make whatever updates we need based on the latest content of GitHub. Also, from the A team perspective, if you can see in the bottom left corner, we have the collaboration tools. We have used Slack, email, Zoom, SMS, among other collaboration tools. I believe this has been a critical part of what we have done during the semester. It has been extremely important to keep communicating, talking to each other, trying to understand what are we supposed to do, and also split the work in a way that everybody can help make this a great game. So from the game player perspective, all they need to play the game is to use to have an internet connection and to use a device that is capable of running a Python script. So right now we are using the game PY, which contains the public IP address of the EC2 game server. It also contains the port that the game server will be expecting to listen from. So once the game player runs this script, which has the IP and also the port, it will send this information it will route this information to AWS. It will reach the edge of AWS. In this case, it's going to be the internet gateway that acts like a type of router. So the internet gateway is going to determine that this is going to the EC2 game server. So it's gonna pass it through, and at this point, it's gonna go through a network access control list and security groups. These are the rules that will determine that indeed the public IP address of the game player and the port that this person is trying to communicate from are allowed. So once it hits this and it verifies that the user and the port are allowed to access the public IP address here, it will send the traffic to the EC2 game server. The EC2 game server, which is an Ubuntu box, will accept the packets. The script running on the server, which is the server PY, will basically grab the connection. It will then present the user the text-based user interface game board, which I'm showing here. So it will show the person welcome to the game. It will ask for the name of the player. It will wait for enough players to join the game, and once that happens, the game starts. So everything that we have seen before are the different tools and technologies that we have used in order to make this game a reality. As you saw before, there are many things running, and there's a lot of technologies and tools being used in order to play the game. Nevertheless, these details are not important for the player. Everything is encapsulated, and from the player's perspective, all they can see, all they can feel is that they connect to the internet and magically they are connected to the server and they can start playing the game. There are not other details that they need to enjoy and to play this game. And this is the intended goal, to encapsulate all the complexity and to make the game easy to use for all the players. With this, I will complete my section. I will pass the stage to Anthony. He will get the ball rolling on the different classes that we have used to build this game.
Hey guys, my name is Anthony Mora and I'm going to quickly talk about some of the main classes and one of the most useful functions we used while developing this minimal increment. The game class consists mainly of a two-dimensional array of integers and a dictionary of positions and their respective description of location on the game board. We use the Python sockets library to set up a server and to bind it to a specific IP address and port number, and then it begins to listen for connections. The server actively listens for connections until there are enough players connected to start the game. The main attributes of a player consist of a suspect, a position, and a set of cards, which are just strings. Now, one of the main functions we used to communicate between the server and client was the send function. There is also a similar receive function that is used to process the data that is sent back from the server or from the client to the server. However, that function is not shown here. Now I'd like to introduce Rem Huden, who will be talking about the class diagram that we use to develop the minimal increment.
So on this slide, we can see how these classes fit into our overall design. Everything really builds out from our server class, which acts as the main controller class for the system. First and foremost, the server class has a game. The game class uses the cards and positions to track state and progress in the play. The server also has a list of clients that are connected. The clients are composed of the player class, which manages its own state similarly to the game class through the card and position classes. The player class also has a notepad. The message class is used to communicate between the clients and server. The primary relationship between these classes that we have is a has-a relationship, which we've symbolized with the solid diamond, the composition symbol. Now Nayila is going to give a review of our schedule.
Thank you, Ram. This is Naila again. Let me give you a quick overview of where we are now with our schedule. We have completed all major documents and skeleton and minimal increments. Everything has been working as expected. In the coming around 20 to 25 days, we will do sufficient unit testing, integration testing, user acceptance testing, and working towards our target increment. Next, let me give you a quick overview of our risk that we have identified early in the development versus now. Here's a risk mastery that we have used. It has impact ratings and it has likelihood. For the impact, we have 0 acceptable, 1 tolerable, 2 unacceptable, 3 intolerable. For the likelihood, we have improbable, possible, and probable. When you look at the left table, here are the potential risk and their rating that we have identified originally. But now we have changed the ratings for a few risks. For the members get sick or drop class, we change impact from 1 tolerable to 0 acceptable. Since we have developed major part logic of the game, it is acceptable risk for us. For merge bad codes, we change the impact from 2 unacceptable to 1 tolerable. Since we have a pretty stable working code base, even someone add the bad codes, we can revert it back and fix it before merging into the master branch. For the design wrong thing, we change the likelihood from possible to impossible, since we have already a working game. And for the team conflict, we change impact from 1 tolerable to 0 acceptable, since we have already figured out how to resolve the conflict, how to be an effective communicator along the way. For the wrong SDLC model, we change impact from 2 unacceptable to 0 acceptable, because at this point, it is not likely to happen, because we have already proved our model is working as expected, and we are making significant progress. For the last one, Like natural disaster, we change the impact from 3 intolerable to 1 tolerable. Since this is November already, and we would not expect any major disaster will happen in the next 20 to 25 days. In addition, we have already secured our code base in GitHub and we have an AWS server running. We should be able to complete our target increment even we have a few days of power outage. Next, I have a Jonathan to talk about the lesson that we have learned over the past few months. We definitely have a lot to share with you all. Jonathan, stage is yours.
Hello, this is Jonathan M. Kelly again. In this segment, I understand I am speaking by myself. However, as a team representative, I believe we learned the following. Team collaboration, then frequent communication is vital. In an expert team, leadership is not always hierarchical. In project management, command and control leadership does not always work. In a design to schedule project, when work is divided, but it forgoes a team addition demand, seek lateral work tasks and parallelisms. This can be mandatory general communication and on-demand specialized analysis. Next, confront errors. This project presented many coding challenges, and we have 2 major solutions. These solutions are the following. Version control. With sufficient documentation, this hardening method can substantially reduce testing requirements. In fact, this was our lead programmer's first practical GitHub user experience, so this leaves growing room. Next is testing. At a high frequency, most code revision was prompted because testing transpired. Next is tutorials. Tutorials are a great assistance. Although our lead programmer became the version decision maker, we can reference our IDE tutorials to have guides in this project if we have to do any work ourselves other than the lead programmer, and in future projects on our own or with other teams. Next, a great project component is learning lessons, and project managers traditionally lead this effort, and I am our team's PM. However, my peers have all contributed project management efforts. So my role is very much and also a systems analysis role. Sometimes a speaker communicating ought to put his audience to sleep. In our project's case, a fun game of Clueless shall interest you, viewer, the entire time. Next is a minimal gameplay demo, a privilege for the A-team to build and shown by our lead programmer, Anthony Mora. Thank you for watching.
Hey guys, my name is Anthony Mora, and I'm going to be demoing our Clueless game and the functionality we have developed so far. So what I have here on my screen are 6 different terminal windows that each represent a respective player, plus 1 terminal window that represents the server. You can see that once I run the server script, it states that the server is waiting for connections. It also goes ahead and randomly picks out a set of winning cards for the game. So to get things rolling, I go ahead and connect each of the players here to the server by running the game script, as you can see that I am currently doing. For the moment, we have programmed the game to set the first player that connects to play as Miss Scarlet, but we are working on adding the ability to choose which suspect to play as. Once all the players have connected, the server initializes the game and starts the game. We can see that each player has their own set of cards, and the game starts with Miss Scarlet making the first move as per traditional rules. For this increment, we have gone with a simple user entry scheme, but in the target increment we shall implement menus and buttons to allow the players to make their choices during their turns. Let's start off by moving Miss Scarlet to the lounge and making a suggestion. We can see that the next player has a card that can disprove our suggestion, so we are now waiting for them to disprove it. On their screen we can see that it shows the list of cards that they can use to disprove the suggestion. Once they pick the card, it is shown to only that single player who made the suggestion. Since it is still Miss Scarlet's turn, we have the choice of either making an accusation or not. For now, let's just select no and end our turn. Now it will be the following player's turn, where they have the option to either make a suggestion, make an accusation, or both, depending on their initial and final positions. For now, we're going to just say no to making an accusation and a suggestion. It is now the next player's turn, and they decide to make a suggestion. They are presented with the same set of questions to pick a suspect, a weapon, and a room. Right now we are looking at a previous player's cards so that we can show that the disproving suggestion functionality actually cycles around all the players. Therefore, we choose a card that the previous player has and wait for the suggestion disproving to cycle back to that player. We can see on the other player's screens that it displays a message saying that they were not able to disprove the suggestion until we get back to that player who does have a card that can disprove the suggestion. We now select the card, and once again, only the player who made the suggestion is shown that card, while the other players are notified that a player disproved the suggestion. The game continues with the next player making their turn. We can see that they decide not to make a suggestion, but to make an accusation. For this turn, we're going to actually make an incorrect accusation on purpose by taking a look at the correct winning cards in the server script. Keep in mind, in the real game, the players won't actually be able to see these cards. We are notified with a message that says we have made an incorrect accusation, but will be kept in the game to help disprove suggestions. The game then continues. Now we are going to show that the players who have made an incorrect accusation can no longer take a turn. Instead, they are just skipped over and are still kept in the game to disprove future suggestions. So right now what we're doing is just selecting no to making a suggestion or accusation if it pops up, so that we can just move along the list of players. We can see that since we are moving into a hallway, we are not presented with the option to make a suggestion. This depends, like I said earlier, on the initial and final positions. Once we end this player's turn, we know that the next player has been kicked out due to making an incorrect accusation previously, and they are just skipped over, and the game continues with the player after that person. We continue skipping a couple more players until we get back to the player that comes before the one who was kicked out for making an incorrect accusation. We would like to show that they are still allowed to help disprove suggestions. So here we are to the player who comes before the one who's kicked out. Now we scroll up a bit to look at his cards so that we can find a card that he or she has. Then we can go back to the player who's currently making the suggestion and pick one of those cards. The player who has been kicked out should be able to help disprove a suggestion and should be allowed to choose a card, which we can see. Once that person picks a card, that card again is shown only to the player making the suggestion, and we can see that the player who was kicked out can no longer make a move. The game just continues with the player after that person. Finally, we would like to show that making a correct accusation actually terminates the game cleanly. This last player will make the correct accusation by looking at the cards in the server script and picking the winning cards. Once he or she does so, we can see that everybody is notified that the game has ended since somebody has made a correct accusation. We can also see that the server has stopped running. We hope you all enjoyed this short demo, and we cannot wait to show you all the final increment. Here is Rem once again to talk to you guys about the features we'd like to include in the target increment.
Now I'd like to quickly go over our expectations for the next stage of the project. For our target increment, we are hoping to include some more features and new functionality. The big goal and expectation we have is to build out the graphical user interface. We are hoping this will greatly improve the playability of the game. Additionally, we'd like to continue to build out the functionalities and classes to improve reliability and security efforts for all potential users. Another feature we would like to add is a UI-based trigger notification so that players can more easily follow what is happening in the game. The last feature we'd like to include is extending the options of available characters and weapons to give the game a unique twist. We are really looking forward to having all these features in a finished product to show. Thank you very much. We hope you enjoyed the demo and presentation.